Hey y'all, welcome back to Math Rescue. I'm Andre, your certified math coach. Today we're going to talk about how to solve quadratic inequalities. Now, this one's a little different from what you're used to because instead of getting a single answer like x equals this or that, quadratic inequalities give you a solution set. That means a whole range of values that make the statement true. Don't worry, it's not as bad as it sounds. I'll walk you through how to find those intervals step by step and show you what they look like on a graph. Let's talk about it. All right. So let's first start with factoring our quadratic. Here on the left-hand side, our quadratic expression. The quadratic expression is already in standard form, and it has a leading coefficient of invisible 1. So factoring is going to be really nice here. To factor, I'm going to go ahead and set up my x games. We want to add to the bottom quantity, multiply to the top. So I want to multiply to 4. I want to add or subtract to 5x. So I think about two numbers that's going to accomplish that for me. Two numbers that come to mind are -1 and -4. Really quick, I could check that. So -1 times -4 gives me a +4, and -1 plus -4 gives me a -5. So those are the two numbers I wanted. From here, I'm going to go ahead and rewrite the left-hand side of this inequality, factored form. All right. My next step is going to be to go ahead and plot the zeros. So this factor right here is going to give me a 0 of x equals 1, and this factor right here will give me a 0 of x equals 4. Go ahead and graph those. Another word for zeros is x-intercepts. Same thing. All right. My quadratic opens upwards. I know it opens upwards because we lead with a positive right here. I'm just gonna kind of create the general shape here. You don't have to graph these to state the solution set. The reason why I'm graphing it is so that you have a visual for what I'm about to explain. So our quadratic inequality says that we have to be less than 0. So let's look at our boundary line, our boundary parabola, and let's consider all the places where the y value is less than 0. If I put a dot here in purple, a dot here in green, and a dot right up here in blue, which of these colors has a y value of 0 or less than 0? Well, the only one that is less than 0 is the green. And so anything in this interval here is going to make my inequality true. So how do we communicate that? Well, if we're using inequality notation, notation is just another word for symbols. So if we're using inequality notation, we can see that x falls between 1 and 4, and that's my solution set. If we had, if we could be equal to, then I would make sure to include that here. But in this case, we cannot be equal to, so I would just leave it as less than symbol. If we want to write that in interval notation, these two notations are the most popular way of communicating the solution set, the quadratic inequalities. In this case, I could say 1 to 4. And this notation just means from this x to that. I'm Andre, your certified math coach. See you next time.